So down here, prove that parallelograms are rectangles. The diagonals of a rectangle are congruent, and the converse is also true. It means that the rectangle is a rectangle if the diagonals are congruent. And we use the distance formula or the slope formula and the property of diagonals to show that a figure is a rectangle. So how can we do that? Well, if we have this rectangle over here, we can use distance formula to show that the shape is a rectangle, because if we're able to prove that BD is congruent to AC, if the first diagonal is congruent to the second diagonal, then we can say that the parallelogram is a rectangle. Right, so we can use distance formula. We can use slope by proving that the angles in the parallelogram are right angles, right? So we can get the slope of BA and the slope of AD, and if they're negative reciprocals of each other, then we know that angle BAD is a 90-degree angle. And then we could do the same with AD and CD. We could do the same with CD and BC. And lastly, we could do AB and BC and compare the slopes, and if they all have 90-degree angles, then we know that the shape is a rectangle, right? So that's what we're doing over here. We use the slope formula. How do we do it? Well, I got the slope of AB, it's 3. We got the slope of BC, the top one, it's negative 1 over 3. And these two are negative reciprocals, which means that angle ABC is a 90-degree angle. Slope of AD is negative 1 over 3. And so AB and AD's slope are negative reciprocals, so we know that the BAD is a right angle. And then lastly, we got the slope of CD, which is 3. And if we compare CD with BC's slope, we could see here that these two are negative reciprocals of each other. So that's also a right angle. That's definitely definitely a rectangle. Then we're using the distance formula. So how do we do that? Well, we found the distance between BD. We found it to be square root 50, and the distance of AC, and we found that to also be the square root of 50. So the diagonals are congruent, so that proves that the quadrilateral is a rectangle. Right? So in the next page, you're asked to figure. Oh, I'm sorry. Yeah, it's going fuzzy. But anyhow, the first quadrilateral, you're supposed to graph it and then use distance formula to prove it's a rectangle by finding the distance of the diagonals, making sure that they are equal to each other. And then on the second one, we're also going to graph it, but we're going to use the slope formula to see if the quadrilateral is a rectangle by checking the 4 angles of the quadrilateral, making sure they're all 90 degrees. So I'll show the answers on the next video.